It's my pleasure to present Dr. Alison Van Eenennaam, Animal Genomics and Biotechnology Cooperative Extension Specialist in the Department of Animal Science at the University of California, Davis. Her publicly funded research and outreach program focuses on the use of animal genomics and biotechnology in livestock production systems. Her current research projects include the development of genomic approaches to select for cattle that are less susceptible to disease and applied uses of DNA-based information on commercial beef cattle operations. Before we begin, some thanks are in order. First of all, we'd like to thank the Office of the Provost, without whose support there wouldn't be funding for an appointment that enables someone to run this series. So thank you very much. And of course, we'd like to thank all of our individual sponsors, without whose support we wouldn't have the funding to host such a dynamic series of speakers to give colloquia on the topics that are of interest to those who follow our lecture series. So thank you very much to all of our sponsors. The Center for Animal Welfare Science in particular for their help in organizing Dr. Van Eenennaam's trip to campus this week. So please join me in welcoming Dr. Alison Van Eenennaam, whose talk is titled Animal Breeding, an Important Component of Agricultural Sustainability or Animal Cruelty.
Thank you very much, and thank you for the invitation to speak here. This is not my normal topic. I'm an animal breeder, and so I'm crossing the line a little bit here, and so I thought what I would try to address today is a little bit about what animal breeders do, and then have a look at how we go about doing what we do, and then give you some examples. And part of my presentation today involves the use of clickers, where I'll get some audience feedback to see what you guys are thinking. And so if you haven't picked up a clicker, put up your hand if you would, and we'll make sure that we do. I don't know if you still have some more clickers out there. We'll make sure we get those to you. I find it's kind of interesting sometimes to see what everybody else is thinking, and whether you're the only one in the room that has a particular opinion, or if everybody in the room is thinking like you. So like was mentioned, I work in Cooperative Extension, which is the outreach arm of the land-grant universities in the United States. So my role is to take the science to the field, and typically I'm working with livestock producers, and particularly beef cattle is my area of expertise. But today I'll be speaking about almost everything except beef cattle. And I guess I will start with these particular animals, where I would argue that animal breeders have made tremendous genetic progress in selecting for a particular phenotype or appearance that they like. And I think if you go home and have a look at your dog, this slide suggests something that makes you really think about which dog breed that you happen to have in your home. But if you look at what animal breeders have selected for here, and these are not obviously food animals, or at least they're not in the United States, breeders have selected for very specific appearances. And along with those breeding objectives, I would argue that there is actually a degree of animal cruelty associated with those particular breeds, because if you look at the 50 most popular dog breeds, each one of them has an aspect of its physical conformation that predisposes it to a genetic disorder. So in other words, if you select for little squashed up faces, you tend to have dogs that have trouble breathing. If you select for great big muscly dogs, then you have issues in terms of birthing and these types of things. And the association of some of these conditions with official breed standards makes conformation extremes an area that really needs to be addressed to safeguard the future welfare of pedigreed dogs. And really, as breeders, what we're selecting towards is a breeding objective. In other words, what is it we're trying to achieve? In the case of pedigreed dogs, it may be the biggest head, or, as my friend John Gibson might argue, it doesn't need to be economic. It might be argued that in many companion animal species, the breeding objective is the maintenance of a ridiculous appearance and congenital abnormalities. And I would argue these two breeds would be classic examples of that. And so breeding objectives have to be carefully thought through to ensure that we're not inadvertently selecting for traits that are predispose animals to congenital abnormalities. And so I think when we're talking about animal breeding, it's not only agricultural animals we have to think about, it's all of the different breeding objectives for different species. So I was asked, how is animal breeding associated with sustainability? And so That term, sustainability, is a little bit like natural. What does it mean exactly? And so I want to give you guys a little bit of thought exercises into what is the sustainable choice using the clickers, which I hope everybody has in their hand. So I'm going to just kind of get you guys going on some clicker slides here. And so basically this is to get you guys warmed up. So this is clickers. Doesn't operate the remote control of your house or open your garage door, so please return them to me when you're done with the talk. All it does is talk to my computer and give me your answer. And so what I'm showing here is a picture of D something A, and this is a smart group here at Purdue. And so you have 4 choices. You can vote many times, just like in Chicago, but unfortunately only the last one counts. So have a think about this, and what my computer is doing is taking in your answers. And at the current time, I've got 35 responses. I don't know how many we got in the room, but I'll say, okay, I got 41, so from now on, when I get to 40, I'll click and go to the next slide. And so this slide is really kind of a suggestion of how smart my crowd is. Okay, well, you're fairly smart, I guess, and there's 5% smart asses in the group, would be my conclusion. Otherwise, you're doing a really bad job in your basic genetics bill, so I could put that down to bad teaching, could go either way. All right, so with that background from the previous slide, I will ask you to start polling now. Given the slide I showed you about the dogs, which of these dogs do you think is my dog? And this slide really, the previous slide was looking for intelligence and jackasses. This one's really looking for mean streaks. It gives me a feel for whether the audience is a hostile audience or whether or not I'm going to have a fairly easy time of it. So I've got 40 responses in, so let me get an estimate of what we're looking at here. All right, majority kind and correct, that's good, and about 50% hostile. So that would be, or maybe, I don't know if number 2 is hostile per se. Number 3, really? Okay, 21%? God, that's terrible. Okay, so with that little bit of background then, and without any further explanation, I'm going to show you 3 different pig production systems. Now, don't respond yet, because this isn't a clicker slide, it's just giving you 3 different choices here. And so there's 3 different options. The first one up the top there, you can see some pigs, they're kept indoors, and there's some veterinarians there, I think doing some evaluations of pig health perhaps, something like that. The second one down the bottom there, you can see the pigs are in outdoor pens and there's people looking at them. And then the third one is some pigs indoors and there's some people outside doing recreation. So without any further ado, I'm going to ask you on the next slide to pick which of these 3 systems you consider to be the sustainable system. So has everyone got their number in their brain? Okay, so don't poll in yet. Now you can start responding. Oh, you're very quick when I cue you up like that, straight in there. All right, I got my 40 responses. Let's see where we are. That's interesting. Almost an even split across those 3. And so whichever system you voted for, you probably think it's the one you think is sustainable, but so does everybody else that voted for their system. And so I think one of the interacting things we often see when we're talking about sustainability are these 3 circles that kind of intersect, and there's this magic white kind of triangle in the middle there that's the sustainable system. And so you've got kind of the intersection of environment and social equity and economic. And typically social equity includes things like animal welfare and worker pay and worker safety. Economics can be economics for the consumer, it can be economics for the producer, and environment more generally is the system's impact on the environment and the production footprint of the different systems. And so there are 3 intersecting circles here, and so unfortunately they often kind of pull against each other. And so my question to you, and don't respond just yet, now you can respond, is which sustainability goal is most important to you? I've got my 40 in. Let's see what the responses are here. So we had 61% said the environment was the most important, 27% said economics, and 11% said social. And most likely, those of you that think social is most important would still think that, and those that think the environment is most important think that. But you have often these trade-offs between these competing goals. And I think that the one point I would like to make is there's often goal conflicts between agricultural production systems, and there's no one utopian sustainable system. They're all going to have kind of pros and cons. And if we go back to this graphic that I showed on the previous slide, what was going on here is these three scenarios that were described in this paper. The first has improved product quality and safety. It has low cost and a kind of an intermediate environmental footprint. The second is improved animal welfare and natural behaviour as the pigs are outside. It has the highest cost and environmental footprint per pound of pig produced. And then third has decreased impact on the environment and the most efficient use of natural resources. Also, you sometimes hear this calling spare the land. The lowest cost and the lowest environmental footprint. So with that little bit of nuance, does that change which of these systems you think is the most sustainable system? And so I'm asking you to again answer the question that I asked you a few slides ago. In terms of the three different systems, which of these do you think is the sustainable system? And we'll just get everybody to respond in here. And so here we're starting to kind of have trade-offs between food safety, animal welfare, and the environmental footprint. As we saw in the previous slide, a lot of you, I think the majority, said that environment was the most important criteria for you in making a choice around sustainable agriculture. But here you have some kind of conflicts. It's like, well, actually animal welfare is really important to me too, but I don't want to necessarily be voting against my environmental being the most important goal of sustainability. And I think what we see is, and what I'm interested in is, how many of you changed your vote from the first time around to the second time that I asked that question? Anybody? A couple of you? Okay. And I'll pick on Bill because you're down the front and I don't want to pick on the students right off the bat. Why did you change your vote?
I wasn't sure what the original pictures were depicting.
Okay.
Their emphasis, and once it was explained what it was depicting, it became clear to me.
Okay, so at first you didn't really have as much information as you needed to make the choice, and then also perhaps you thought about the goal conflicts and which one was the most suitable to yours. And I think this often happens with these types of questions, and in terms of which is the most sustainable question. And there are almost always goal conflicts in different production systems, and each fulfills different aspects of sustainability because no one system can fulfill all sustainability goals at once. And the authors of this scenario paper said the problem is, because we don't have any objective metrics to kind of evaluate these, the evaluation and ranking of sustainability goals gets mainly left to the politics, or particularly I would argue marketers, to say that theirs is the most sustainable system. And it really exposes the process to subjective interpretation, especially by special interest groups who perhaps rank their particular sustainability goal above all else, and they don't really care about or think about the impacts on the different attributes of sustainability. They're only interested in one aspect. And I think what we see is there's so many different voluntary labels out there that suggest that their particular system is the most sustainable system, and you could just about justify any system as being the most sustainable system depending upon what ranking you put on those particular sustainability goals. And in this room, we don't have agreement as to which is the most sustainable system. And I think that that's a really important thing to kind of take on board, that what I consider to be the most sustainable system won't necessarily be what you think, because we have different weightings in terms of which aspect of sustainability is the most important. And there's a whole lot of labeling recently, the do not contain labeling, does not have this, did not do that, you know, the clean food that we see now as distinct, I guess, from the filthy food that we ate before. And those types of kind of pejorative suggestions that somehow the other people's food is inferior in some way is really taking off in a marketing perspective and really giving a lot of misleading information in terms of, you know, you'll see, for example, you know, non-GMO oranges. Well, there are no GMO oranges, or, you know, we don't add hormones to our chickens. Well, you're not allowed to add hormones to any chicken. So putting it on there kind of suggests that the competitor is doing something that's actually not actually happening. In California, we have an interesting group of people that live out there, and I saw this sign that said, if we each grow a large crop of different food, we could all trade with each other and eat for practically free. So maybe food is free. There's a nice sustainable system, but there was a nice little snarky tweet that went along with this and said, yes, and since some people are better at growing food than others, we could have them do it so that we can do what we're good at, and we could trade them things that we make for food, and we could call the people good at growing food farmers. I really do think that's an important thing to keep in mind, because it seems like it's quite popular to malign farmers, and they are actually the ones growing the food at the moment. So I want to talk a little bit about plant and animal breeding and how it fits into overall sustainability, to get back to the kind of the topic of this lecture, and particularly look at how prior to the 1900s we were selecting animals and plants, but we weren't really making a lot of progress in terms of overall yield or footprint. And so this is just corn, and you can see basically different breeding methods getting implemented into corn breeding programs and changing the slope of that line in terms of the rate of genetic gain towards, in this case, average corn yield per acre or hectare. And we can show a very similar story for dairy cattle production. And what you can see there is that inflection point back in the 1940s that was basically enabled by the introduction of a breeding method by the name of artificial insemination, not artificial intelligence, you computer guys. So that was basically, you can see a real inflection point, because as animal breeders, what that enabled us to do was utilize the very best males in terms of their daughters' milk production much more widely throughout the population. And effectively what we did was we increased our intensity of selection, which accelerated the rate of genetic gain. And you can see this precipitous increase over time that's been subsequently enabled by additional breeding methods that I'll talk about in a minute. But what's interesting is if you look back at the historical literature, in the early stages of introducing this particular breeding method, and I'm interested in breeding methods and particularly the controversy around certain breeding methods as associated with modern biotechnology and GMOs, there was really analogous concerns around the introduction of this breeding method when it was introduced. At the time, the general public was against research that had anything to do with sex. Associated with this was the fear that AI would lead to abnormalities and that it was against God. And finally, and this is not unusual with the introduction of any technology, probably in any industry, there are obvious winners and losers in the introduction of artificial insemination. And the obvious losers were going to be people that sold bulls. Because if I can now inseminate my cows with a straw of semen, I don't really need to buy your bull anymore. And there was certainly a lot of pushback from influential cattle breeders who saw this as a competing business interest against their particular interests. And for sure, it has put a whole bunch of bull breeders out of operation. And similarly, as the productivity of cows increased, a whole lot of farmers have gone out of business as a result of that. And that's not unusual for there to be both winners and losers as it's associated with the introduction of new technologies. And although I think maybe social media has exacerbated the adoption of new technologies, it's not a new thing for there to be public opposition to the introduction of technologies. So name this particular technological innovation that this quote is associated with. It's unknown what long-term health consequences may unfold. The studies are not adequate. Furthermore, it will likely not be available or cost-effective for small farmers, and it will decrease product acceptance and consumption. Does anybody want to hazard a guess as to which technology we're talking about? Come on, give me one. Yes? GMOs, close but not quite. Pasteurization, 1924, that was stated. And I think what I find compelling as a breeder is, yes, there's been tremendous increases in productivity, but what has that done to the environmental footprint of our agricultural production? And I think the majority of you here said that from a sustainability perspective, environment is a very important one to you. And basically what this shows is, as compared to the 1940s and comparing it to the 2007 production systems, bottom line is that a glass of milk has about 1/3 of the greenhouse gas emissions per glass of milk that it did in the 1940s. In other words, because a cow can produce more milk per unit of cow, you are actually decreasing the overall greenhouse gas emissions. Similarly, we've got only 21% of the animals that we had in 1944, so back then there was 30 million odd animals, using 23% of the feed, 35% of the water. It goes all the way across there, and so the overall industry greenhouse gas emissions is about 59% per unit of volume, or whatever you want to use as your metric, but per unit of product in that particular industry. And I think this slide kind of captures it perhaps more succinctly for many different industries. So here we have soybeans, corn, dairy cattle and broilers, and the 2014 total production levels in the United States. This is just the United States graph. And then in 2014, the amount of land that was required to grow those corns and soys. I'm in the right place to talk about those two crops. And the number of head of cattle that were used in 2014 to produce that amount of milk or that amount of broilers. And you notice the broiler number is very big. So we consume somewhere around about 9 billion broilers in the United States annually right now. If we had kept our productivity levels at 1950s rate, the additional land that we would need and the additional animals is shown in that last column. So we'd need about the land mass of the area of California to grow the soybeans, land mass of both California and Texas to grow the corn. We'd need 30 million additional head of dairy cattle if we were at 1950s production rates. And we'd need a shocking 8 billion additional broilers to produce the same amount of broiler meat that we produced in 2014 if we had maintained the genetics where they were in the 1950s. And so there's an obvious environmental footprint associated with not allowing the use of those breeding methods to improve the productivity per unit of animal or per unit of cow or per unit of land. And one of the technologies that's really enabled the improvement of dairy cattle milk production recently, and more recently I would argue many of our different plant and animal species, is the integration of genomics selection into identifying the best animals, the best plants to be parents of the next generation. So before we had genomics, we kind of knew who mum and dad were, and we knew mum and dad were pretty good. But for any of those of you that have siblings with the same parents, you'll know that Mendelian segregation means you get a very different hand dealt to you depending on the luck of the draw. So some animals that come from good parents are genetically superior and others are genetically inferior. And what genomics kind of allows you to do is use the power of the genetic variations that's located throughout the genome to basically act as little molecular markers or flags to say whether an animal got good genes from its parents or bad genes from its parents. And it allows you to look under the hood of Mendelian segregation at a very young age and say which of the animals from a particular cross are going to be the ones you want to use as parents of the next generation, because they got lucky in Mendelian roulette and got the very best genes from their parents. And basically, the way that this works in dairy cattle production is we have very high accuracy artificial insemination bulls, and we're basically able to take their phenotypic performance and match it up with their genotypes and see which genes are associated with superior performance. And based on that information, then I can take DNA from a young animal and predict, based on its DNA, what its likely performance is going to be. And so that particular technology has only been around about, 7 years now. Back in 2009 it was introduced, so less than a decade. And what you can see is the rate of genetic gain in terms of dairy cattle production since 2009 has effectively doubled as a result of the integration of genomic selection into breeding programs. And the reason for that is we're now able to actually take those young bulls as they're born from elite parents and say whether or not they're going to be genetically superior based on the DNA that they happen to inherit from their parents. And so what that enables us to do then is to accelerate our rate of genetic gain. Back to my original statement, are we accelerating our rate of genetic gain in a good direction or a bad direction? Are we driving twice as fast towards burning out these cows and selecting for high-producing animals that are unhealthy and have bad welfare? Or are we going twice as fast towards animals that are optimally suited for their production system? And so what I'm going to ask you is, this is a clicker question, so pick up your clickers. I talked about selection objectives, and I want to ask you, in 2017, what weighting is given to milk yield in the selection of dairy cattle? So I mentioned that we can select for dogs with long ears. If you're selecting for dairy cows, presumably you want animals that can produce milk. So I want to ask you, what weighting in 2017 is given to milk production in the selection of dairy cattle? So has everyone got their clickers to the ready? Okay, I just got to my 40, so that means I get to move to see what the responses are. Okay, so 20% of you said 100%. That's the only thing that dairy producers care about, or dairy breeders, I should say. The majority of you said 75% is put on milk production. 2% of you said less than 10%. And I'm guessing that may have been the animal breeders in the room, because that's actually the right number. And you're like, what? Hang on, we're selecting dairy cattle, but we're not putting any emphasis on milk production? How can that be? Well, let me explain how that is. So this is a history of the USDA selection indexes for dairy cattle production. You can see from 1971, shown across here, is the original index, and all they cared about was milk and fat, because that's what they got paid for. Damn it, we can measure that, we're going to select for that, that's good. And then it was like, well, great, we got these high-producing cows, but they maybe didn't get pregnant. Well, okay, that's actually important. We better start including that in our selection objectives. And so what you see here is, over time, breeders have started to include other traits that make that cow more suited to her production system. So it's not only milk yield, but also whether she has a long productive life. In other words, she's there for many calves. Whether she has somatic cell score, which is an indicator of mastitis or udder inflammation. Her characteristics that make her well suited to walk around the dairy, so type characteristics. Whether she gets pregnant. And finally, whether she is able to have calves easily. And what you see is the net merit breeding objective in 2014. The weighting on milk is actually -1. That's milk volume, because basically what they're getting paid for is fat and protein, and so that's positively correlated with milk. But so there's about, 42% weighting on those productive traits. And the rest of it is actually on all of the other traits that make her an optimally suited dairy cow. So historically, breeders were myopic. And as we get new traits and phenotypes that we can include in this, then yes, we'll expand it and have even more traits that we can make a so-called balanced selection objective. And so that's where we are now. But I want to play you this little radio recording from a couple of ladies in New York City who are discussing the use of genomic selection.
So the latest thing is that there is now a move away from proven bulls. That's bulls that have grown up and shown us what they can do by fathering some daughters. Basically, we can scan so much genetic information so quickly now that breeders are moving to something called the genomic bull. So that's where you have a bull who has never fathered any calves, but you put his DNA on something they call a bovine chip, and it lets you look at 800,000 different genetic markers. And all of that information allows you to give the bull a lifetime net merit score, even before he's ever sired a calf to prove his worth. It's a huge cost saver for artificial insemination companies. They can cull males whose genomes don't look good at under a year old, rather than having to spend money for food and housing until the bulls are 5 and can reproduce.
In a weird way, it's like plant research. With genetic markers, we don't have to grow a full corn plant to know what it's going to be like. That technique has become really important in agricultural research. But applied to cattle, it's efficient, sure, but it's also kind of disturbing.
Yeah, kind of like a Gattaca thing where there's this genetically inferior underclass that gets culled. And you know, the weirdest thing about it is that in some ways with these genomic bulls, we're just getting further and further away from seeing them as an animal. Which brings us back to the difficulty of treating animals well when we're seeing them as numbers on a spreadsheet rather than living, breathing creatures.
So I think that's a really interesting little radio clip for many reasons. I think one of the most interesting things to me is the kind of the distinction between agricultural research and doing experiments on corn, where you take a seed chip and select the parents of the next generation, versus doing the analogous thing with animals, because basically breeders work by selecting the parents of the next generation to be the dog parents of the next generation or the corn parents. And we deny the opportunity for genetically inferior animals and plants to have offspring. That's kind of what breeders do. And so that whole discussion about the Gattaca, I think, is really interesting, because if we weren't doing that, I guess we just have random mating occurring and there would be actually no genetic progress. And so it's, I think, an interesting perspective. And the assumption that breeders are, by definition, cruel because they're looking at numbers on a spreadsheet rather than that they may be actually trying to select animals that are optimally suited. So there's that assumption there that breeders are treating animals cruelly. And I guess that's maybe the genesis of the talk that I'm giving here today is that assumption warranted? And I think one of the most shocking slides, and maybe some of you have seen this before, is the difference between broiler animals from old genetics. Oh, sorry, I've got another technological innovation for you to try to guess what I'm talking about. We've recently advanced our knowledge of genetics to the point where we can manipulate life in a way never intended by nature. We must proceed with the utmost caution in the application of this newfound knowledge. What do you reckon they're talking about? Anyone hazard a guess? You can go with the same answer. No! Luther Burbank, back in 1906, talking about basically hybridization and the creation of new plant breeding technologies. And I guess I always have to remember that it's not unusual for there to be concern around the use of technologies in agriculture. But this was the slide that I was thinking was next. And that is the difference between broiler chickens from 1957 and broiler chickens from 2001. So these are the same environmental conditions, same feed, different genetics. So the line at the top is 1957 genetics, where you can see that it took about 85 days to get a broiler through to market weight. Whereas today's modern broilers are getting to market weight at, I think, 41 days, maybe even less than that by now. And you can see if they were taken out to 85 days, they would be very big birds indeed, and that's not the weight that we typically cull them out. And basically, the 8-week-old body weight of a broiler has increased from 80.81 kilograms to 3.15 kilograms over that particular time. How did the breeders accomplish this breeding objective? Well, this is not genetically modified chickens or GMOs. These are chickens that have been selected using conventional breeding. And back when they first started to do this, the only selection was on growth. And that's not unusual for animal breeders as they first get going. But now I think it's important to know, for example, in the selection of broilers, that a number of traits are recorded. So in the case of broilers, about 56 individual observations are made per pedigree candidate. So these are potential parents of the next generation. And so, for example, Cobb Vantris uses more than 50% of these traits are some measure of health or fitness. And so similar to the breeding objectives used in dairy cattle production, the breeding objectives used in poultry production underscore the importance of those health and fitness traits in terms of who becomes the parent of the next generation. So it's not just growth and feed conversion efficiency, it's also health and fitness that go into it, and particularly feet and leg problems, which were an issue with breeding, have been incorporated in. So they now measure the angularity of the leg and things to be able to select for animals that are not lame or having feet and leg problems. And so the current breeding programs have been able to combine both of those together and make positive genetic improvement in both the productive measures and also the health and fitness traits. And so at the moment, the US growth rates and meat yields continue to improve by about 0.74 days per year and 0.5% per year for a broiler, whereas the feed conversion ratio, that is how much feed is needed to produce a pound of chicken, is decreasing. And at the same time, the livability, that is the survival of the birds, is improving by 0.22% per year, and the condemnation rates, in other words, animals that fell out of the system because they weren't able to cope with that system, have decreased by 0.7% per year. And similar to the dairy cattle breeding objectives, if you include those health and welfare objectives in your breeding objective, even if the traits are genetically negatively associated, you can make slower genetic progress, but you can make genetic progress towards both of those objectives, or both of those considerations, if you include both of them in the breeding objective. And so that's what the chicken breeders have been doing. And as I mentioned earlier, if we hadn't altered their production, then we would need about 8 billion more chickens getting grown if you assume that we eat the same amount of chicken we did in last year, or 2014, if we hadn't made those genetic improvements. But I want to talk about what's going on, and I'm seeing a trend now. So Whole Foods Market has announced that they're only going to stock slow-growing chickens, okay? And so as a breeder, I look at that and I go, okay, that's going to have some competition with my sustainability goals, because I'm now going to be having more feed per pound of gain. That'll be in a bigger environmental footprint. What are the other attributes of sustainability? And I think that what really frustrates me is the metrics that they're using to say this is that they've committed to replace fast-growing chicken breeds with slower-growing chicken breeds. Nothing else about how the chickens are being raised is changing. So what they're basically saying is that they're going to only stock chickens that basically will be around about 14 more days before they get slaughtered. And why? Well, according to their global meat buyer, the slow-growing bird is a better, healthier chicken, and at the same time, a much more flavorful chicken as well. Okay, I would love to see the objective evidence base for that statement, because the flavor of a chicken, I think, is mostly going to be defined by its diet. And these chickens are not getting any different diet, and they're not in a different housing condition. So if you're going to say that they're going to be more flavorful, why would that be the case? And they're going to be better and healthier. Well, that doesn't agree with what the data is showing in terms of the animals having increased survivability and decreased condemnation rates in the current breeding programs. And I think that why would slow growth equate to a more flavorful chicken if none of the other production parameters have changed? And so basically their trigger for what they're going to allow to stock in their particular production systems is that the animals are not allowed to grow any faster than 50 grams of weight per day on average over their lifetime, versus the conventional hens that are, or broilers, that are growing at 61 grams per day. What is the objective scientific basis for 50 being the magic number, or less than 50, and 61 being unacceptable? And if less than 50 is good. Does that mean 30 is better and not growing at all would be ideal welfare? I mean, there's no real kind of evidence base to support that assertion. One thing for sure, though, is that those chickens will be around 14 days longer and that they will basically have a bigger environmental footprint and they'll be more expensive. So you've had two big impacts on two other pillars of sustainability for a perceived or a suggested improvement in the animal welfare aspect of sustainability that isn't actually documented by any evidence to support what is being said. And so I guess I would finish with don't believe everything you read on the internet just because there's a picture with a quote next to it by my good friend Abraham Lincoln. And you know, I do have some credibility in this area because I'm actually a chicken rancher myself. So those are our 5 chickens there. So my son got this for his FFA project, and we really do enjoy our chickens. We actually have them inside, and I love raising chickens, but I also understand this is not going to raise 8 billion chickens, right? And I think it's important to differentiate between what is required to produce the food that we're producing and what is realistic in terms of this. And I think that putting forward, without any evidence, that just randomly increasing for 14 days how long it takes for a chicken to get to market weight with no supportive evidence base really, to me, doesn't support, certainly not my sustainability goals. And I guess I'm interested if it supports your sustainability goals. So I think I have the last clicker question for you guys now. So which chicken would you choose? So I choose not to eat chicken. I'm going to take the slow-growing Whole Foods chicken that's going to be more expensive. They acknowledge that and will require more feed. Conventional chickens, which are the least expensive and require the least feed, or an entirely different production system, free-range chickens, which will be the most expensive, the slowest growing, most feed, and will also be exposed to predation, disease, and cannibalism, because that was kind of one of the reasons that they went inside in the first place. And so, again, even a choice that many people choose for animal welfare considerations also has some kind of competing goals from a welfare perspective as well. And so I think there was some interesting data that was done by Joy mentioned Michigan in terms of which is the most sustainable system for egg production. So they compared aviary housing or conventional cages, or just I'm not sure what the correct term is, but just basically free running around. And they basically found that probably the aviary cage production system was the one that kind of optimized most of the different considerations from a sustainability perspective, because there was decreased cannibalism and decreased leg problems in that system than in the free running around system. But interestingly, irrespective, some companies, McDonald's for example, has said that they're going to go to that open system, even though the scientific data wouldn't actually support that as being the system that's probably in the best interest from a hen welfare perspective. So let's see what do you reckon? What do you guys reckon is going to win this competition? I guess you all guessed the one you picked is going to win this competition. Otherwise, you wouldn't have picked it. So let's see. Okay, 71%, and an even split across the other 3 options here. So that's, and I've never actually asked that question before, so I'm not sure what I was expecting, but that's an interesting result. Except that 71 plus 30 is 101%. That's very frustrating for a type 1 person, but anyway. So I'm just going to speak about, why I think breeding is important from a sustainability perspective, and because I see genetic improvement as a permanent and cumulative endeavor. So once you've made a genetic improvement, you don't need to keep doing something to make that animal have that particular appearance. And if you can select for disease resistance, which is what my program focuses on, it's really a better solution than having an animal get sick and needing to be treated with antibiotics and chemicals. And I think there's some interesting new applications with some of the newer molecular techniques, particularly some of the gene editing techniques. And I actually will put up a couple of examples here of what breeders are doing, and then finish with one of the projects that's happening in my lab. And this is a group that's working to try to solve the problem of PRRS in pigs. So that's porcine reproductive and respiratory syndrome virus, which is a $6 million problem in the US and a more than $1 billion problem in Europe. And a group at University of Missouri has actually been involved in knocking out the protein using gene editing where the virus attaches and gains entrance to the animals. And basically these pigs are just disease resistant against this particular virus. And that actually is a product that a company called Genus is trying to take through to market. And I would argue from an animal welfare perspective that selecting for animals that are disease resistant is actually in an animal welfare friendly condition. And this is a project that my lab's working on in collaboration with the University, University of Minnesota, so Scott Fahrenkrug, who's founded a company called Recombinetics. And basically what we're trying to solve is the problem of horns in dairy cattle. And because I do a lot of public outreach, I actually prepared a little video that explains this. And so rather than me going into the details, I'm going to let this video explain it. If you look at our dairy cows and our beef cows, there's a lot of differences between them. So dairy cows have been bred to be very optimal for dairy production. And as it happens, that brought along the horned phenotype. In other words, dairy cows grow horns. If we look at our beef animals, they've been bred for optimal beef production. And as it happens, Angus, for example, is a breed that doesn't have horns. And we don't really want horns in dairy production systems because the animals hurt each other with the horns and they can hurt the human workers.
It's a widely accepted husbandry practice that we dehorn cattle, both for the safety of the cattle as well as for the safety of the people that take care of the cattle and work with them. The way that the disbudding procedure is done here routinely is we will administer a lidocaine block. A lidocaine is a local anesthetic similar to what you might get at the dentist's office for a procedure that might be painful. And then we use an electric dehorning or disbudding instrument that provides heat around the horn bud to kill the cells that would grow the horn. The consumers are concerned about the way we care for our dairy animals, and they expect us to do a good job of providing care and being concerned about animal pain when we have to perform procedures. So I think it's important that we keep those factors in mind and do the best job that we can to try to minimize pain and discomfort.
We're working in collaboration with a company called Recombinetics, who had a vision to try to use precision breeding or genome editing to introduce genetics from Angus cattle to the Holstein dairy breed to produce dairy cattle that don't grow horns. And so we haven't altered anything about all of the genetics that makes them great milk producers and you know, all of their Holstein genetics is still in place. What we've basically done is a very precision technique of just introducing one trait that we want, which is polled or hornless, and we haven't altered the rest of the genetics.
With the change in technology, it looks like that we can achieve the goal of having calves born without horns and not have to give up the genetic capability of those animals. So it looks like a win-win situation. We've still got very productive, efficient dairy animals, and we now have the opportunity or possibility of no longer needing to dehorn or disbud dairy calves.
So in summary, I think agricultural breeding programs do align with many sustainability goals, but that doesn't have to be in conflict with animal welfare. And we can include animal welfare and well-being considerations in our breeding objectives. And there's a number of groups working on disease resistance for trypanosomiasis in Africa, and also single gender animals in industries where one gender is the one that makes the product, and egg laying would be an obvious one where that would be an example. And I guess to me, you know, this sustainable definition, this is a definition of sustainability that I think it's pretty hard to argue with. A way of raising food that is healthy for consumers and animals, does no harm to the environment, is humane for workers, respects animals, provides a fair wage for the farmer, and supports and enhances rural communities. Well, that would be like arguing against applehood and motherhood and apple pie, right? But there are those trade-offs, and so it's very difficult to get one that can tick all of those boxes simultaneously. And I hope that we can all agree that more people need to be fed better with less environmental impact. And if we start on that shared goal, then the appreciation that there's going to be sustainability goal conflicts with any production system. And depending on the metric that's being used, in other words, the relative weighting you put on those three goals of sustainability, people can come to different conclusions. And I think that that's a really important thing for everyone to keep in mind, because it's quite frustrating to see someone making a different choice to what I would make, but it's probably just as equally frustrating for them to see me making the choice I make, because I have different weightings as to what I consider to be the most sustainable system. And that, in summary, breeding programs have dramatically reduced the environmental footprint of food production. I think that one's is evident in the data. And as I said, it's permanent and cumulative, which is where, as a breeder, I think it's a really important thing. And once you've accomplished it, disease resistance, for example, you don't need to keep vaccinating or treating for antibiotics or whatever, because it's embedded in them. And there are a number of useful traits, including disease resistance and welfare traits, that are in current breeding objectives. And so the assumption of the ladies that were being cruel and selecting for only milk production, I think isn't actually what's true if you look at the breeding objectives. And sure, improvements can be made, but it can only be made by including it in those breeding objectives, so that we appropriately weight what the correct weighting is on the welfare traits versus the productivity traits versus the other traits in the index. And to me, and what I find frustrating, and I think my biggest argument that I have with people who say no to certain technologies, is that I think, you know, a lot of these breeding methods can complement genetic improvement that can be accomplished using traditional selection. And I would much rather have a discussion around how we could use all of the technologies, rather than saying, well, you can't use this, or this is the best system, so your system's bad. But how can we have a more kind of nuanced discussion around, well, there's always going to be trade-offs with different technologies, and not tie breeders and farmers' hands behind their back by just suddenly banning particular production practices or breeding methods. So thanks for inviting me, and I was fairly good about leaving 35 minutes for questions. Sorry guys, I did my best.
Okay, so you have time for questions. If you, I'll give you the microphone, you must turn the switch on, ask your question, and turn the switch off. For the sake of the recording.
This is not going to be a very friendly question.
Okay.
I lost 4 relatives in the Holocaust: Auschwitz, Buchenwald, Sobibor. And so the following statement by I.B. Singer resonates with me, and it is, for animals, every day in a factory farm is an eternal Treblinka. That's the background for my question, which is, how in the world does one justify the gratuitous infliction of pain and suffering on innocent, sentient, autonomous creatures?
So that's really not a question to do with animal breeding, but more generally, should we eat animals, I guess? Should we eat sentient animals? And I'm sure that's a good philosophical question. It's not my expertise. I'm an animal breeder. And so I think we can open that discussion here, but that's really not the questions that I was addressing in my talk.
Using the animals to be either eaten or used for milk or whatever. I mean, you're treating them as commodities.
Uh-huh.
So what in the world is the justification? and they're autonomous creatures. I would think you'd agree with that. So what entitles us to use them in that way?
Well, I guess that's more generally a question about whether we should eat animals, right?
Well,
And I
more
guess,
more basic than that. That's one aspect of that. I mean, I'd say there's also aspects of zoo animals, aquaria.
I think that it won't get picked up by the recording.
I mean, and that's one. The eating of animals is one aspect of it, no doubt.
And that's certainly,
and the biggest.
So in your opinion, the 100% weighting in your evaluation of your diet is that animals shouldn't be eaten. And I think that my point is that different people have different weightings, and that's certainly not my weighting. I eat animals, and I actually think that animal agriculture is an important part of our diet. But we disagree. So your weighting is different to my weighting.
So is there any disagreement about the rightness or wrongness of inflicting gratuitous pain and suffering on innocent, sentient, autonomous creatures?
Well, I guess I disagree with that particular assertion. I don't think that's what we do in animal agriculture. So that's, again, we've got different value systems. And so is it okay for you to not eat animals and me to eat animals? Or do I have to take your value system and not eat animals because that's what you think?
You ought to act morally, but that's tautologous.
Well, to me, that's kind of inflicting your value system on me. To say that, it's suggesting that I'm
so the
being
Nazis,
immoral.
when they killed my relatives, that's their value system and that's my
Well,
value
I mean,
system?
I think there's a little bit of a difference, in my opinion, between the Nazis and eating a broiler chicken.
There's a difference, but the moral point is the same.
Well, that's where I disagree with you.
Well, I don't know how much of the I mean, I'm not a breeder, and I give you...
Well, and as I said when I accepted this appointment, I'm a breeder, and I'm not a philosopher, and I'm not an ethicist. But I also think that what you're suggesting is saying that your value system should be what I take on board, and I don't.
To be clear, here's my value system, to put it in your words. I think it's morally abhorrent to needlessly inflict pain and or suffering on innocent, sentient, autonomous creatures. Now, if that isn't your value system, good enough, but I think you'd be in a very, 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 very small minority.
Well, I don't think that is true because the majority of humankind eats animals. So if your argument is that by eating animals that's inflicting pain on them, then I guess that's again your opinion, and I don't think that's shared by the majority of the population.
Oh, I'm certain you're wrong. I mean,
Okay.
I'm certain you're wrong about my what I call the principle of gratuitous suffering. Not to be make a long story, but I'm sure virtually everyone in the world would agree with that.
This could go and go and go. We should get a different question.
People behind you that have questions.
So regarding labeling, when we're talking about all of these anti-GMO, no artificial hormones, no antibiotics, what are your opinions on where we need to come socially in terms of education to improve our food system with all these labels that are basically fear-mongering against competitors?
Yeah, the labeling, especially the absence labeling, I think is really, so all of the labels you just mentioned are voluntary processed-based labeling. In other words, there's no, it's the process that they're saying, you know, we don't use this, or it's grass-fed or free range or whatever, and it's appealing to a market segment that thinks that's an important part of what they want to choose in their diet, similar to what I was saying about we all have different values as to what we want to do. And I guess to me, if I want to sell unicorn poo free, you know, spam, and someone wants to pay me extra money for that, so be it. You know, I really think that that's what marketing is. You know, I think what really frustrates me is when it's being marketed by slandering your neighbor. So Coke and Pepsi are fierce competitors, you'd agree. But Coke doesn't say, Pepsi will give you cancer. Coke says, drink me and you'll get a better girlfriend and have a great time, right? They market the superiority of their product rather than demonizing their competitors. And if they did, Pepsi would sue them. What's happened, unfortunately, I think with agriculture is you've got, you know, clean meat or whatever that's kind of demonizing their competitors, but it's not a two-player marketplace. It's just, well, all of conventional agriculture by definition is dirty. And it's kind of, they're getting a one-up by suggesting that their competitors are inferior or bad in some way. And unfortunately, that does lead to misunderstanding, but you can't stop marketing. And so I guess I would argue, you know, sell your product because it's better, rather than having to malign your neighbor. And the fear-mongering, unfortunately, is being financed by the groups that are often making money out of, well, that'll give you cancer, so buy my stuff because it won't. Even though that's untrue, fear is a very strong motivator. And it's much easier to scare people than it is to reassure them. I mean, look at the vaccine debate we have going on. You know, I think we've got a lot of these kind of, I don't know, fake, what are they called, alternative facts that are going on around a lot of these kind of scientific topics at the moment. And a lot of it is driven by fear-mongering and these competing business interests suggesting that, you know, if you go with their product or their healthcare or whatever, you know, it's better than this competing one that's dangerous. And so I don't really have a good answer for you other than, well, that's marketing, and that's obviously selling well in the marketplace, and that's why they're doing it. I don't think it's good for the long-term sustainability of agriculture, because I think often what's getting demonized is the very technologies that are helping to improve the environmental footprint of agricultural production. And the more technologies we take off the table, the bigger our environmental footprint. And I don't think that's a great thing to happen.
Thank you for your presentation. I'm going to touch a little bit on Mark's question, but I want to tie it back to what you're really presenting on. So if one of the arguments against meat eating is about pain and suffering that animals experience, and I will say there are valid points to be had there. Based on what you presented, I've heard lots of conversations about the use of genetics, genetic editing, to do things like, for instance, select against animals that feel pain, select against animals that might suffer in some of the environments that we put them in. Can you speak a little bit about your knowledge of any of those technologies, and do you think they're really feasible?
Well, I mean, editing is a great tool, but it is kind of, at the moment anyway, more geared towards Mendelian qualitative traits. In other words, traits where one gene makes a protein that's virus attacking. I think a lot of the traits that control personality, for example, or behavior, are going to be good old Mendelian quantitative traits with hundreds, if not thousands, of loci. And I don't think, A, we have the understanding of the biology sufficiently under control, or B, even the technical capacity to edit to change an animal's behavior, for example. I mean, we might be able to do something very bad to it that I don't know, basically invalidates its feelings or something, but I just don't think we have the biological understanding to do that type of thing. To me, editing is very useful for single gene traits like POLD or disease or coat color, or fixing genetic defects in our dogs, but I don't personally think it's got a lot of utility at the moment for those more quantitative kind of traits. I just don't think we're there yet. But I guess, you know, if there's a way to breed animals that are disease resistant, for example, I think we should. I think that aligns with sustainability goals in my evaluation of production systems.
I'm just kind of curious about like your job. Like, I know you're a breeder, but like, what's like your day to day? Like, where do you work? Like, in a lab, in an office, on a farm? Like, just kind of, what's your Job description, I guess.
If I had one day that was the same, I could tell you. So my job description is 75% extension, 25% research. So I have a molecular lab, and I have 4 graduate students that are working on different projects, mostly on disease resistance in beef cattle, and using editing and also using genomic selection. And then, well, as most research professors do, I spend a lot of my time writing grants to get funding to fund the graduate students, because you guys are expensive little creatures. And animal research is expensive too. And then a lot of my time is spent speaking to farmers about how to use genetic selection, or, you know, EPDs, estimated breeding values, or the selection criteria we use in beef cattle. How you might go about using genomic selection, for example. We know the concepts behind that, so explaining that to farmers. And then probably recently, a third of my time is spent talking to more general audiences about GMOs and more generally agriculture, because as the population gets further away from agriculture, there's a lot of misunderstandings around really basic attributes of agriculture. And, you know, I think that a lot of my time is spent dealing with that, especially in California, where we'll have initiatives to ban this, that, and the other, without a real understanding of what the trade-offs are associated with that decision. And so I guess one of my main messages is always trade-offs. There's trade-offs, and it's nuanced, and let's just have a discussion around that nuance, because just saying no and banning this or doing that has really big implications sometimes that are not really intended or even well articulated, often not well articulated by the groups that are pushing them, because it does make it quite complicated. You know, we have the initiative process in California. You're probably familiar with the caged egg or caged hen ban, Proposition 2, that went through there. There was a labelling initiative on GMOs. Well, there's a lot of different initiatives that go through, some very unusual ones, I must admit. I won't even go into one of the ones that was on the last ballot, because it took me a little bit by surprise. But yeah, so those, unfortunately, to try to get things through the political process, there's a real push to make things black and white, like vote yes on this because it's good, and, you know, no on this is bad. And almost nothing in life is that simple. And so I guess that's, so a fair bit of my time is just on public education in various attributes of that.
Thanks for your talk, Alison. It's been very interesting. You know, we hear a lot about the growing population, and the demand for meat is going to go up with it. Do you think that animal breeding can actually produce enough meat in the next 50 years? You know, at 2 and 3% a year, can we actually get enough through animal breeding, or is it going to require biotechnology to do that?
I think it'll, you know, I guess back to my point, I don't want to take any safe technology off the table. I think it'll take all our tools and all the production systems. I'm not maligning any one production system, but I think the question of that in, you know, Africa is a really different question to the one in America, where, you know, maybe we could quite happily decrease our meat consumption, whereas in other parts of the world there's a dietary benefit to increasing it. And what makes sense in terms of animal breeding in the United States with, you know, dairy cattle production is a really different thing to what makes sense in pastoral regions. And so I guess it depends a little bit on what region you're in as to what makes the most sense. I mean, I think even in Africa, if you look at the productivity of their cattle in terms of dairy production, you know, it's the yield per day is very, very, very low, in part due to the feed resources. Even just increasing their basic management, and even recording animals as to which ones are the good ones and not eating them. I think there's productivity gains that can be made using very simple technology. And so, yes, we might need fancy technology in some places, but we need some really simple technology in other places. And I would argue a good extension system would go a long way to helping there, and it just doesn't exist, And so different places will require different things. But I do think it's important, especially in African countries, to look at the fact that animals are not only food, they're also draft power and manure and wealth storage, and a couple of chickens can really help with the overall health implications for the children that have access to that protein versus families that don't have any animals. And the importance of animal protein in the diets of the chronically malnourished is a really different question to us in the first world, where we have plenty of protein options out there that we can choose from if that's what we ask. And the role of livestock production systems in the billion or so rural poor that depend on them as part of their livelihood, I think is often dismissed in the first world discussion around whether we should eat less meat or whatever. And really those nuances of environment and the relative to what you already have access to, if anything, a little bit of animal protein in a very malnourished diet can really help in those diets. And I think that's a really important consideration when we're talking about those types of environments. That's not part of our first world discussion here.
As you mentioned a few minutes ago, that you spend a lot of your time talking to the public about our agriculture system. Do you have any recommendations on how we, as most of us I'm sure are students, can talk to the public, our family and friends, or even our own colleagues about our animal agriculture system, especially those who are already opposed to it, since it's been shown to be difficult to change people's opinions, even if you throw the scientific facts at them?
Well, I think it's difficult to change your opinions, especially if you throw the scientific facts at them. And so I think there's a really interesting body of social science research in terms of what does change people's minds, if anything, and what are effective communication strategies. So scientists have traditionally used the deficit model, which assumes that if only you knew more about the topic that I know a lot about, and I impart that wisdom to you, you'll change your mind, because if you knew what I knew, you would change your mind, which assumes that knowledge is what makes people make decisions. And knowledge has actually very little to do with what people make decisions about. A lot of it depends on their emotions and their gut, their social group, who they interact with, and those are the trusted people that they're going to get their messages from. And so if you come in as Madam Scientist and impart the knowledge, if they have no knowledge of you, they're not going to listen to a word you say, basically. And so what the social research says is to try to find common values or shared values. And I would argue a lot of people think that more people should be fed better with less environmental impact. That's a hard one not to agree on. And so if you have that shared understanding, can you then move on to a conversation from there? And it's not typically how scientists interact with people, because we're very logically minded usually, like data drives us, and actually, I mean, I do make decisions based on data, and I want evidence to support statements that are being told to me. I'm not going to just go with what Dr. Oz says, even though he's very appealing to my emotions, and so that's enough to convince me what the data says, but that's not normal, right? That's not how normal people make decisions. And so understanding that and not getting frustrated at the fact that data doesn't change people's minds, and understanding that it's actually our job to do a better job in communication to help with the discussion, rather than just being frustrated that, oh, the public's so stupid, they don't know anything about agriculture. And it is frustrating, especially when you hear misinformation getting sprouted out there as fact, and you know that that's actually not true. But I don't know that we have a really good way of getting science communicate, well, have a look at where we are with vaccines, where we are on global warming, you know, GMOs. I mean, the scientific consensus there is very, very strong, and yet the public opinion, especially on GMOs, is you know, I think 37% of the public think they're safe and 88% of scientists. How do we get that gap, right? That's nothing to do with data. That was created somewhere else, and I would argue that's created by fear-mongering. That's kind of driving the business to alternative business interests in that regard. So it is very hard for science to compete against fear, and in this alternative fact world, it's a little bit scary actually, and so. There's a march for science on the 22nd of April, I think, that is, you know, kind of trying to encourage scientists to speak up and the importance of evidence-based decision-making in our policies. And I think it probably doesn't take a rocket scientist to figure out why it might be happening around about now, but that's, you know, I think a really important thing, and a lot of scientists are asking that question. How do we get the message out there? Use the mic just so that it gets...
So I was just going to say, as scientists, one thing we might need to do is stop expressing our confidence intervals and our uncertainty levels, because that is the leverage that that is always used against us to say, see, they're not really sure, you know, because you'll say, you know, state things in a probability or some kind of acknowledgement of uncertainty is just the very weapon they need to not believe you. And if we just stop doing that, but as scientists we acknowledge that there is variation and uncertainty, but it's just a confusing principle to the public. You know, I can say it's, you know, 40 degrees outside plus or minus 5 degrees, and our EPA chair would say he has no idea what the temperature is. Right, and that's one of the scientists' biggest problems, I think.
Yeah, I mean, I think we have to be true to the data, though. So I hesitate. Yeah, I hesitate to suggest that we have that level of certainty, though, because if you ever find a scientist that says X is safe, you know they're not telling you the truth, right? So you're always going to say it's as safe as X, or it hasn't been shown to show harm, because you can't ever prove that. And so I think you've got to be careful to maintain your scientific integrity and still get a simple message out there. Yeah. The only people that will say things with certainty are the people that are not scientists. And so I think you risk, you know, saying this is safe you know, that's just, it kind of suggests that you're not really expressing the nuance that's associated with science.
What happened to vaccine people?
Yeah, yeah.
Being honest that, yeah, some people have problems.
The vaccine is such an interesting thing, because it actually can harm your own kids, not having them vaccinated. As a mother, I find that, like, okay, GMOs, eat it, don't eat it, nothing's going to happen to my kid. But not getting vaccines, I mean, they might actually die. I don't know how much more compelling of an argument I can make than that. And yet still have people not vaccinating is kind of amazing to me. But that's because I base mine on evidence, I guess. So.
There's a hand back there.
So I have a different question entirely for you now at this point. So where do you see the greatest potentials for increase in sustainability? Do you have a specific species in mind that has the greatest potential for increased sustainability? Do you have either a specific species, or also could you provide a comparison between either crops and animals? Which of those two groups has the greatest potential for improvements in sustainability?
Well, I hate to say everything. I mean, I guess I don't want to. It depends on your environment and what grows there, right? And what's currently taking it down. So I was involved with a project in Uganda where the bananas are, getting this horrible bacterial wilt disease that's just wiping out that crop. In that particular situation, a simple disease-resistant banana that didn't get the wilt would basically double their productivity. And so that's a solution for that particular crop in that particular country. you know, in wheat it might be rust that is going to. So I don't know that I see any one particular species or one particular kingdom. I think, you know, it's all of it together is kind of what we need to do. But there are very low yields in developing countries where very simple technologies could help improve those yields. And those, I think, are probably the low-hanging fruit of productivity gains. I mean, a lot of modern agriculture, we're already, you know, getting pretty good yields and, you know, are able to address many of the problems using the technologies we have here. It's, I guess, the countries where they don't have access to those technologies where the potential low-hanging fruit of making the difference between the potential yield of crops and animals versus their actual yield is the most evident. And so that, I guess, if I was going to focus somewhere, if someone made me God, would be those places, because I do think the potential gains are quite large.
In that discussion, I was just wondering if I can think out loud about something that I've been thinking. So I'm originally from India, so all of South Asia doesn't raise cattle, like beef cattle, right? The beef that they eat is either the spent dairy cows and the male calves that are born in the dairy industry, and then the buffaloes. Traditionally, you know, contrary to popular belief, India does eat beef, because if you have a dairy ecosystem, somebody needs to be eating the beef. Otherwise, you're going to be run over by cows and cattle. I've always, and then currently in the current environment where the moral police, you know, the vegetarian moral police, then the environmentalists, and others who oppose beef eating specifically, and there's a religious component to it, they kind of use the beef cattle production models to justify why they are opposing beef eating in India. So there are a lot of states that have banned cow slaughter. So I just, you know, it just worried me on two aspects, that the local folks can get to eat beef, but someone's exporting them, but with this false justification that they are somehow saving the environment, and everybody else is eating beef. So I'm sorry, I know I'm rambling, but this is the first time I'm actually thinking out loud about this. And I know it's hard for systems where beef production by itself is an industry, and the beef, and I enjoy good steak, so I understand. Is there ever a day when beef will be primarily from dairy cattle? I guess now it just becomes hamburgers, I guess. Does that make sense? Like, would that be a tiny bit of an answer to his question, or no?
Well, so, I mean, if you look back in time, we used to have mixed dual purpose breeds of dairy cattle, right? So they were animals that were used for both beef and dairy, and the selection went towards, you know, the Holsteins for their dairy production. The males do go into our beef supply, just to be clear, the young male calves. So and actually, if you finish them in the feedlot, they will grade choice, and they'll be perfectly, the steakhouse near Davis actually stocks Holstein beef from males, so that does actually happen now. Old cows tend to go to hamburger because they're tougher and not as juicy. But India is an interesting example. So which country in the world has the largest cattle population?
India.
Yeah, so that's a really interesting scenario, and I guess since we're in a philosophy class here, it's kind of interesting to think about the biggest carbon footprint from a cattle perspective is likely India, but the meat is not getting consumed by people, well, for religious reasons. And I often think about this with our pets as well. So my dog and all of your dogs are probably eating meat, and hopefully your cats are at least getting some so they can get their essential amino acids. And yet they're creating no food for humans. And so the carbon footprint of our pets is probably pretty big. So we should all get rid of our pets if we're going to be true to trying to decrease our carbon footprint. I've never actually heard anyone realistically suggest that people should do that. And then of course, you should have less kids and all of that. But those the animals in India that aren't producing any food but are producing that carbon footprint from being there, for religious reasons, should we get rid of them, those cows? Because they're not producing anything.
So I happen to believe that what is understood as the Indian model is actually, the truth hasn't come out yet. Like historically there have been people who did eat beef. Like I said, someone's got to eat the beef. Otherwise you cannot let cows outlive, so there have been groups, social groups, but what has happened is it's a social outcast situation. And what we think of as Indian diet is actually only the upper crust, the elite diet, which is not represented by everybody. So I think the latest studies say about 60 to 70% people eat meat. What I want to share is there's been a study recently that says all the abandoned cattle that wander the streets of India, like how much they cost the farmers. So farmers are suffering. So it's only in the last 30 years or so that there's a ban against slaughtering. They've always slaughtered previously, and somebody has eaten that beef, and now there's a ban, but at the same time, India has also become the largest beef exporter, not just the largest number of cattle heads, largest beef exporter in the last 2 to 3 years. So someone's making money out of this. So the current environment is they're making use of religion, politics, and everything to physically suppress people from eating, even though beef has always been eaten underground. Am I making sense?
I'm not familiar with
the
situation.
There's a lot that doesn't get studied and that doesn't get communicated and talked about. So there's there's that recent study that estimated the production losses in about billions of dollars. And it doesn't take into account that rural abandoned cattle actually compete with wild herbivores. So there's that environmental problem also. But it's very hard to communicate these things, Sorry to take up time.
Yeah, interesting.
Yeah, but that's a whole, you could talk for a whole 2 hours about what's happening in India.
Everybody, let's join me in thanking Dr. Van Eenennaam for her interesting talk. Thanks.